All right, I'm recording.
Good morning. Our project is Kick Park. My name is Bubakar Chusu. I'm the action analyst of the group.
My name is Ayman Alim. I'm the pessimist of the group.
My name is Odette Bryant, and I'm the optimist of the group.
My name is Emmanuel Arsate, and I'm the spokesperson and recorder for the group.
My name is Mohammed Hassan. I am the leader of the group.
The objective of our system is to design one that will allow users to find a parking space in advance. Through the use of sensor-based methods and vision-based methods, they will be able to do this. The overview of our design. In this presentation, we're going to cover our activity views, our work breakdown structures, our Gantt charts, our cost summary, and our testing.
All right, we're going to discuss our system structure. What this is a level 1 diagram of how our system is going to work. We broke it down into 5 different components so that we can easily illustrate how the system will work. It will take pretty much 3 inputs. One is going to be the user request. The user is going to request a specific lot that they would like to park in. That information is going to go through our user request handler and enter into our distance calculator. The system will also pull information from the GPS of the cell phone or the mobile device and actually figure out how far away the car is from the lot that they requested. Also, this other module here is our space detector. It will determine what spaces are available within the parking lot, and all this information will be fed into our determination module. The determination module, the main purpose of this module is to give the user the best place to park. So it's going to do all the calculations to figure out which probability they have of getting that parking space based on the information that they have available. And then that information will be sent to the display model, which will be pretty much a graphical user interface so that the user can actually see which lots are available and also have some kind of a mapping data that will actually guide them to that parking lot or show them where that parking lot is. What we did for our diagram, we used an activity view diagram. We figured this was the best way to kind of illustrate how our system was going to work. There are a lot of components that happen in parallel with each other, and we try to illustrate that. First here we have the parking space request. From the information of the mobile device, what we're going to get is the user is going to request where they want to park. Our system will also post to the lot detector what their request is, and also post to our distance locator to kind of figure that information out. And on each of these lines here, they'll identify their preferences, the lot will be selected, and then it will go to this unit where it can actually display that information. But along the way, this system here, as far as the lot detector, will actually obtain the number of vehicles in that spot and give it a tag. So it knows that lot 1 has this many spaces, lot 2 would have so many spaces, and so on. And this next portion here will actually extract the GPS information, compute the distance, and also compute a probability of the likelihood of the user actually finding the space, and also display this out, and then this is where our flow chart ends.
Oh, okay. So this is a work breakdown structure. This is the first step typically in planning a project. So what it is just a hierarchical breakdown of the task and the deliverables that you need to accomplish in order to make your project work. So this is this is a part of our work breakdown structure because we have like 2 pages of this, so we just decided to put one part of it, and I'm going to explain what it's doing. So first, we have our activities that we identify, and then we describe each activity, and then we assign a person who is doing the activity, and then we estimate the number of days or the time is required for the activity to be completed. Also, we include the resources, like the resources you need to use in order to complete those activities. Also, what we do is we try to make the connections between those activities. So as you can see here, we see activity 1.3 depend on activity 1.1 and 1.2. That means this activity cannot be done if those activities are not completed. So this overview of work breakdown, we have it on page 10 if you want to look for the complete WBS. So next we move to the Gantt chart. Okay. Okay, so what Gantt chart is just a bar representation of timeline. So this shows effectively our work breaks down and the time needed for it to be complete. Also, we have some arrows that show the relation between those activities. So here, as you can see, we have the number of days plus the start and the end of each task. So all those tasks that we have there, they are already in the work breakdown structure. Now here we just put them and they give an overview of the timeline, how those tasks will be completed.
In our specification requirement, the most two important functions is the parking space availability and the display interface. For the parking space availability, the system must provide an available spot for the user search criteria. Let's assume the user looking for McNair parking lot. So the system should provide him with the data on the McNair parking lot. So by this way, we're gonna reduce the distraction for the user. And also the display, it depends on which kind of display. If we're gonna use the app, and that's what almost we're gonna do, it's just gonna be a simple app, so don't cause any distraction for the user. And also this is our cost. It is very, very low cost project. It's contained with 8 sensors. Each one is $399. The total is 31, and microcontroller, and wireless transmitter, and XB Arduino shell, and wires, with the total cost of $261. It's very low cost project.
Right. So what I'm going to talk about is the test case that we came up to basically test one of the modules that we're already in the process of developing. So that test module is based upon the engineering requirement that basically allows the user to input their request of the lot they want to park at. So as far as like the actual testing goes, first the application icon has to be selected on the Android operating system, and then the application opens to the main page of the application. Now the next thing that's going to happen after there, the actual visibility of the application has to be appropriate for the actual user to be able to distinguish what they're looking at, and so it doesn't cause any distractions as part of our engineering requirements as well. Now, after that happens, the request of the lot can be selected now after that. And then the screen should display which lot they want to park at, and then they will be able to request an alternative preference as well as time goes on in case that parking spot is not available anymore. So, go to the next slide. What I would like to do now is actually show our user interface, and I'm gonna walk up to the camera so it's a little bit easier to see. So what we got going on right now is just the basic app, which is called our Quick Park app. So what happens is, like, you just press on the button and our app comes up, and it even plays a little sound now, a little car parking. So it comes up and it actually shows you like a little map, which is going to determine where you want to actually park at. So what you have to do is you got to select the parking lot that you can park at, and then you just select McNair, and then based upon McNair, it'll show that you selected McNair, and then if you wanted to select Martina, it'll bring that up as well. Now the next thing that we've also went ahead and done is we've used the user's GPS location and the module, and then as far as our future development, we'll talk about that in a second. But if you just press the GPS locator there, it actually brings you up to the exact location of the user. So as our future development, we're going to actually take that to come up with our distance calculator module.
All right. So getting back to what we've talked about as far as our future development, what we've done so far, as you've seen, we've done the portion of the app that actually gets the user requests, as you saw back in our first diagram. What we're going to do is work on testing different components to make sure that we're retrieving the lot data for our lot data module. Also, we're going to be working on, like Emmanuel said, the GPS information, where we're going to extract the GPS information from the mobile device or the smartphone, and we're going to pretty much integrate all these systems and components together. So as far as solution strategies for continual development, what we're going to do is approach each part of our project the way we've approached every single step so far, doing the work breakdown structure, making sure that we have the information that we need, making sure that we're keeping on track with our work breakdown structure, and we're also going to continue to just follow the process. If any hiccups come along the way, we're going to make sure that we still stay strictly guided by our work breakdown structure and our Gantt chart. And we'll also, what we're working on for the future is also system integration, working on having our lot data information populate on the mobile device or on the cell phone for our particular users. What we're doing here is just to make sure that this app actually works. We want to make sure that it's confident so that the user can feel that we have a reliable system, and we're trying to reduce errors. So moving forward, that's our goal, to make sure that the system is as precise as possible.
Do you have any questions for us, Dr. Afghan?
Yeah. So what are the metrics that you have considered to decide which parking spot is the best? Is it just the distance?
What we're going to do is use actually different values. So distance and the number of parking lot spaces that are available.
Right.
So the lot that has the most spaces available will be the best choice. Mm-hmm. So we will suggest to the user this is a possible best choice for them, but ultimately the user has the ability to choose which lot is best for them.
Yeah.
But we'll give them suggestions as the goal of our application.
And to go on that a little bit as well, like some of the other metrics we can use is like if other users are logged into the system, if someone else is closer to that specific parking lot, maybe it'll give them like less chance of actually getting that parking space, and someone else is already looking for that parking spot and they're closer.
That's actually the answer I was looking for. That's good. So you don't want to have like congestion for single parking because
Exactly.
everyone is like routed to that one. So you need to have a like fair allocation for the parking spot. And also, I think you can consider the cost. So maybe like McNair can have like a better price comparing to other ones. So you can consider that one too. So are you, did you finally decide to have your own network? So either a car is in your network or not, or it's going to be like for everyone? Do they need to pay to be in the network that you have or not?
I think we did not decide about that yet, but because say we think about students,
Mm-hmm.
so probably we are going to develop it to think about more of those options
Mm-hmm.
so far in our future development. But so far we're just thinking about for a student.
Okay.
Yeah, maybe not have the actual users pay for it, but for the people that actually want to provide that service to pay for it, like such as a university
Mm-hmm.
or a parking deck, for them to actually pay for that visibility, not the actual users, because it would be kind of unfair to them, I think.
That's right, I agree. So you can also like have a metric for the hours of operation for each of the parking spots. So maybe someone is like they're gonna close at 5 p.m. So you can also have it as an input for your program. I suggest you may even add an RFID tag for each of the cars that you have, so you can recognize if this one is like allowed to park here or not. And it's not going to be very costly. If you want, you can add it to your cost table. So, so I saw your app. That was good. Good job, everybody. Are you able to read the GPS data right now from any kind of cell phone, or is something that you're gonna have for your future work?
For the future work, we could put it on other like platforms, but as far as like right now, the app can easily be put into like any Android device.
Mm-hmm.
And I mean, later down the road, we can make it work with other operating systems as well, so other people can use it.
So you can get the data for the GPS on the cell phone and have it like an input for your program, right? You can
Yes.
do that. Okay,
Yes.
good. Okay, good job. Thanks.
Thank you very much.
Yeah.